In this video we're going to look at a formal proof for the sum of the terms of an arithmetic series. So an arithmetic series is similar to an arithmetic sequence, except for the fact that the terms in the sequence are added together as we go. So we're going to start off by writing out term by term what the sum of an arithmetic series would look like. And I'm going to use Sn to represent the sum of n terms. So the first term we use the letter A. The second term is going to be A plus D. So it's the first term plus a common difference of D. The third term is going to be A plus 2D. And this continues up until A plus n minus 1D, which is the final term of the sequence or the series. I'm then going to rewrite this, but I'm going to rewrite it backwards. So the last term is A plus n minus 1D. The second to last term is A plus n minus 2D. The third to last term is A plus n minus 3D, and so on until I get back to the first term, which was just an A. And I can see here that each term in the first way of writing it is going to pair with each term in the second way of writing it. So the first matches with the last, the second with the second to last, and so on. And I'm going to add together these two series. So 2 lots of the sum of the series is, and I'm just going to put each of these terms in some square brackets for a minute to help keep them separate from each other. So A plus n minus 1D added to A plus D plus A plus n minus 2D added to A plus 2D plus A plus n minus 3D, and finally we've got A plus n minus 1D plus A. I'll put the dot 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 in at that point to show that that's going to just continue up until this term, which is going to be the final pairing. And now I'm going to simplify what is in each bracket. So this is A plus A is 2A, and then I've got n minus 1D, and here I've got A plus A, so I've got 2A, and I've got n minus 2D, so I'm going to expand that. So I've got nd minus 2d, but then I've got plus d, so that actually is just minus d. And here I've got A plus A is 2A, and then I've got, or if I expand this, I've got nd minus 3d, but I've got add d here, so that's just minus d added to, and then here I've got 2a plus n minus 1d again. So 2Sn is 2a plus n minus 1d added to, if I factorise this part, I get 2a plus n minus 1d added to 2a plus n minus 1d, and so on. So every pair adds together and can be simplified to look like this. So how many of those have I got? Well, I've got n pairs, so it's n lots of 2a plus n minus 1d, and then I can divide through by 2 to give me the sum of the terms is therefore n over 2 multiplied by 2a plus n minus 1d, and this gives me a formula for the sum of n terms of an arithmetic sequence, or an arithmetic series I should say. This is given to you in the formula book, but you are expected to be able to reproduce this proof as well.